next type of relation, so that is the inverse relation. So here to understand inverse relation, so let us consider R be a relation from set A to set B. So we will consider a relation R, so from the set A to set B, so that is R belongs to A cross B. So that is R belongs to the Cartesian product of the set A and B. So that is R belongs to A cross B. The relation R inverse, so written in the symbol like this, so R raised to the power of minus 1. So this is the symbol for writing R inverse, is said to be an inverse relation if R inverse from set B to A is denoted by R inverse is equal to a set containing the ordered pair elements B comma A such that A comma B belongs to R. So I hope the definition of the inverse relation is clear. So that means we can define a relation from the set A to set B, so that is R so belongs to the Cartesian product of the set A and B, or we can write this as R belongs to A cross B. So the relation R inverse is said to be an inverse relation of R if R inverse from set B to A is denoted by R inverse equal to the set containing elements B comma A such that A comma B also belongs to R. And let us consider the case where throwing of two dice. So if we throw two dice, so then there will be say possibly about 36 outcomes we may be able to write. So now if R equal to say 1 comma 2 and 2 comma 3, say if the possible relations we can form, so while we are throwing two dice, is R equal to a set containing the ordered pair elements 1 comma 2 and 2 comma 3. So then R inverse can be written as a set containing elements 2 comma 1 and 3 comma 2. So here we are writing the inverse in this. So instead of writing 1 2 we write it as 2 1 and 2 3 we write it as 3 2. So that is nothing but the inverse of a relation. So here the domain of R is the range of R inverse. So here the property associated with the inverse relation is the domain of R is the range of R inverse and vice versa, and also the domain of R inverse is the range of R. So all these, so these two are vice versa. So this is another property of the inverse relation. So I hope now, so this example will make us understand the meaning of a inverse relation. So let us take say some more example to understand the meaning of an inverse relation. Say suppose if xy belongs to R, so if x comma y belongs to R, so this implies y comma x belongs to R inverse. So this is how we can write a inverse of a relation. So if x comma y belongs to R, where R is the relation, so then this implies y comma x belongs to R inverse. So this is inverse relation. So thus if R equal to a set containing x comma y such that x belongs to A and y belongs to B, so then R inverse is equal to a set containing y comma x such that y belongs to B and x belongs to A. So this is also another way of understanding the inverse relation. So now we can understand further say by taking some more examples. Say we will consider one more example, say relation R. So can be consider another example of a relation R such that it containing a set of elements of ordered pairs A comma 1 and B comma 2, C comma 3 and D comma 4. So now the inverse of the relation R inverse can be written as a set containing elements, so 1 comma A, 2 comma B, 3 comma C and 4 comma D. So I hope now So this example will make you understand the actual meaning of a inverse relation. So I hope now, so you are clear, so with the definition and meaning of a inverse relation. So now let us take up